All right. This video is about angles in quadrilaterals. As we've seen, we've already defined all the quadrilaterals, so we know what a quadrilateral is, right? The four-sided shape that it's a closed four-sided figure or four-sided polygon, I guess is the best way to say it, because that's the definition they gave us. All right, so what we want to take a look at is what are the angles in a quadrilateral? So let's make up a random, we're going to start, let's just draw a random quadrilateral. It doesn't matter anything about it. It doesn't matter. It could be any sort of quadrilateral. Doesn't have to be perfect. Just has to have four sides. Okay, made it up. There's four sides. Great. So what I want to do is I want to figure out what's the total angle measure of this random quadrilateral. If we were to look at a rectangle, for example, I think we could figure out exactly what the angle measures of a rectangle would be. But is that true for all quadrilaterals? So before we figure this one out, let's take a look. Here, if we put together a rectangle, the definition of a rectangle is four right angles. Right, so we have four right angles. A right angle is how many degrees? 90, right? So 4 times 90 gives us a grand total of 4 times 9 is 36. Put 0 on the end, so 360. So the total angle measures of a rectangle are 360. And we can say the same about a square because part of the definition of a square is that it has four right angles. But what about a quadrilateral, right? Because here, we could argue this is acute, right? We have an acute angle here. These would be greater than 90, so these would be obtuse. So could we say for sure that a quadrilateral has 360 degrees when you add up all the angles of a quadrilateral? Well, there's one really cool way of finding out. So what I'm going to do is I'm going to take this quadrilateral and do the same with yours. So this random quadrilateral here, connect two opposite corners or vertices of that quadrilateral. And now we've created how many triangles? Two, right? They have the first triangle and the second triangle. And what we could say about these two triangles is that we have this angle, and this angle. So these three angles of this triangle, we know this triangle is going to add up to 180, right? So the angles of triangle 1 add to 180 degrees. And a very similar story for triangle 2. So this angle, and this angle. So the angles of triangle 2 add to 180 degrees. So is it as simple as saying 180 plus 180 is going to give us a total of 360 degrees? Well, there's one piece that we have to figure out, right? This angle was split into two different angles. So could we argue that this big angle here is the sum of these two smaller angles? And that answer is yes. So this angle here plus this angle are going to give us the total for this one angle here. So now what we could say is the angles for triangle 1 is 180 degrees. The angles for triangle 2 is 180 degrees by the triangle angle theorem. So now we could say that the angle measures for any quadrilateral will add to 360 degrees. So this is our most important thing that we could ask, that we could say about the angle measures of a quadrilateral. The angle measures for any quadrilateral will always add to 360 degrees. And we can prove that by using two different triangles, okay? So any quadrilateral will, all the angles, these four angles are going to add up to 360 degrees. All right, so now that we know that, right, this is our most important thing that we have learned, right, is that the angle measures of any quadrilateral are going to add up to 360 degrees. So what does that look like as far as in practice? Well, here it's asking us to find the angle measure of the indicated angle. So that would be the question mark right here, this question mark. So we have 1, 2, 3, 4 angles, and we know that all four of these angles have to add up to 360 degrees, right? So what does that notch mean again? Oh, that's the right angle. So that's going to be 90 degrees. So if we add up all four of these, the total then is going to equal 360 degrees. So what I'm going to do is I'm just going to add all four up and set it equal to 360, starting here with 81. So 81 plus, and this angle here is 90, plus this angle of 100, plus, let's call it x, right? Because it's a question, we don't know. So call it x, all equals 360 degrees. And now we can add these up, right? 100 plus 90 is 180. 100, or yes, 190. 190 plus 81 is 271. So x plus 271 equals 360. And now we can subtract 271 from both sides. And x equals whatever in the world that is. We have to borrow? Good night. 10 minus 1 is 9. 5 minus 7, I gotta borrow? Shoot. 15 minus 7 is 8, and 2 minus 2 is 0, so 89. So that means that this angle right here is 89 degrees. Okay? It's really just that simple. Add all four angles and set it equal to 360 degrees. Now, what happens if the angle measure is an expression? So let's take a look. Here, this is asking us to solve for x. To solve for x. So I have 1, 2, 3, 4 angles. We know that this is a quadrilateral, and the angles of a quadrilateral all add up to 360 degrees. So I'm going to go one at a time and add them all together and let it equal 360 degrees. And it doesn't matter where you start. So x minus 9, so x minus 9 plus x minus 8, x minus 8 plus x plus 14 plus x plus 31 equals 360 degrees. Now, we have this big, long, gross thing, right? So 1, 2, 3, 4 angles all add up to 360 degrees. Now, what do we do next? Right? We have to combine like terms, much in the same way that we combine like terms here. 81, 90, and 100 gave us 271. So down here, what we're going to do is we're going to combine all of our like terms. I have a positive x, positive x, positive x, positive x. So here I'll end up with 4x. Negative 9, negative 8, positive 14, and a positive 31. Well, negative 9 and negative 8 is negative 17. A negative 17 plus 14 is a negative 3. Negative 3 plus 81 is a positive 28. And all of that equals 360. Okay, now subtract 28 from both sides. Minus 28, minus 28. We're left with 4x equals, well, see, I have to use my calculator on these. I'm not that smart. I'm not that smart at all. So, where's the calculator? Oop, update. You know, you think you'd be prepared for stuff like this. Okay, so we have 360 minus 28 is 332. Okay, so 332, divide both sides by 4, x equals, okay, so 332, we're going to divide by 4, and we get 83. All right, so our value of x is 83. Now, whenever I'm done, I want to go back and ask, did I answer the question? All the directions say is to solve for x, and we got x by itself, so that indeed is as far as I have to take it.